optimization. Concave upwards. I put here a plus. I'll let you know why. And here, somehow, it does like that, like the sine or cosine, you know? Concave downwards. And it does like this. Concave upwards. At this point, you get a relative maximum, okay? It means relative because it's not absolute. It's not absolute because this is the value and the value is greater than, you know? But calculus always works in a neighborhood. This is a maximum for this neighborhood, you know? Then it is relative. Calculus always speaks about relative maximum or relative minimum. If you have two maximum, relative maximums, you have two, and you don't have more, this one is the absolute maximum. If you don't have this relative minimum and relative minimum, this is the absolute minimum, but you have to compare them to say that it is absolute or not, because calculus only gives you relative ideas in a neighborhood. In those places, f prime x gives 0, you know? The tangent is horizontal. If this is a relative maximum, if this is a relative minimum, whenever f prime x equals 0, x is known a critical point. But when I say a critical point, I mean really xy. To find the real point, you have to calculate the y also. But the calculus gives you the x. How you find the x of those critical points? Using the derivative, doing it equal to 0 or making it equal to 0, and then find x as an equation, you know? Sometimes a function goes like this and seems to have a maximum here, seems to, but really what it is doing that. Is concave down, and this is concave up. Chain of
concavity.
This form is calculated using the second derivative. When a function is concave downwards, the derivative is less than 0, you know? The second, in the intervals where the function is concave downwards, the second derivative is less than 0. That's why I put a minus here, you know? In the interval where the function is concave upwards, the second derivative is greater than 0. If f second x is continuous, this is continuous, a continuous function, like this one. If here is negative and here is positive, a continuous function. I'm not talking about f second, any function. That over here is negative and over here is positive, you know? If it is continuous, somehow to get here has to cross over here, yes or no? If over here is negative and over here is positive, and it is continuous, somewhere has to happen. That's how you find this point, you know? I'm sorry, I'm not talking about the derivative, I'm talking about g in abstract, you know? If the second derivative is continuous, which is regular in your courses, going from negative to positive, over here, it has to be 0, because it's going from negative and suddenly it appears positive. Has to be 0 somewhere over here. Then you name those critical points. But if f prime x equals 0 and f second x equals 0, this is named an inflection point, which means that concavity is changing either from positive to negative or from negative to positive, upwards to down or down to upwards. That's the way that you check the chain of concavidad. Now, when you draw a function, how good are you graphing functions using? Are you good in that? This is a kind of optimization, because when you graph, you find maximums and minima if they exist, you know? This is an optimization problem. But now then, we're going to what the book calls applied, okay? Applied, then over here. Read that, and I am gonna ask you some questions. Read please, example 1.
Okay. A garden is to be laid out in a rectangular area and protected by a chicken wire fence. What is the largest possible area of the garden if only 100 running feet of chicken wire is available for the fence?
Then you have a rectangular area where is a garden, is a fence, and it says that it's not for the chicken to go there to the garden. Then it says that the area, it names this X and it names this Y. But here it says that you have 100 feet of wire. It means that this plus this plus this plus this is just 100. This is a function. You can find the Y against the X. Just moving the 2x over here and divided by 2. Explicit formula for Y. You need this, but they are asking about the area, which is given by this formula. Find the maximum area. It means maximize this product if 2x plus 2y is 100. Maximize this product if 2x plus 2y is 100. This function has two variables. Unfortunately, it has two variables. I cannot find the derivative because it has two values. I have to leave one value. Then, from here, they get y equals to that. And then you substitute over here. And you get now that the area is a function of x. And it gives you this function. Now, it's a problem of calculus of one variable. Find the maximum of ax given by this function, but it says that x is between 0 and 50, okay? Let's see why they find that x is between 0 and 50. Because when this x is 0, here, see my pen? When x is 0, then 2y is 100. Then y is 50, you know? When x is 0, you don't have any fence. And it gives y to 50, right? But you don't have any fence, you know? But anyway, near to 0, y is 49,99999. And when x grows, y
decreases.
Then when x is 50, y is 0. And when y is 50, x is 0, you know? That's what it says that the x is between 0 and 50, you know? And sure, when you are in 50, you don't have any fence because the y is almost 0, you know? Anyway, but you may not care that I feel. You go to the calculus and say, okay, to find the maximum or minimum, I have to find the critical points. It means find the derivative, doing it equal to 0, and finding the x. 50. This should be 50 to give 0, and then x is 25. 25 is a critical point. The abscissa, or whatever it is named, the x. I have ax equal sy, 2x plus 2y equal 100, right? I got the idea that x is between 0 and 50. And find the maximum, the max, if it exists, of ax when x is between 0
and 50. Suppose
that you have here the 0, you have here the 50, and you have the function ax. I don't know really how it is. At this point, you have to find a prime x equals 0, and I did that. Y equal 100 minus 2x over 2, y equal 50 minus x. When x is 50, y is 0, you know? And when x is 0, y is 50, you know? After that, you replace and say, with this, you got ax equal sy, two variables, but this is equal x
times 50 minus x.
and it gives you 50x minus x squared. You have critical point. I don't know if it is that an English word?
No, I don't
No.
know.
You speak about coordinates. Is that right or not? You name the x and the y, and in Spanish, I feel that in English should be something like that. Ordenada. Let's see. Almost the same, huh? With double S. And see that word? Ordinate. Yes, the x and the y. Right? Critical points. When I use that, this is not the critical point. It is the x. Then you have to find y a prime x, where ax is this one. Then f a prime x is equal to this one, 50 minus 2x equal to 0, then x equal to 25, right?
Right.
Possible. Max, mean, or
Neither.
the worst case, inflection point. We mean this, max, that the function goes like this. Mean, that the function goes like this. Inflection, chain of concativity. Now we don't know maximum, minimum, or inflection. If f second of 25 is greater than 0, it is case. Okay? Right? See that?
Yes.
That's why I call this that in that way. And it's not difficult to remember because in the x's, those are the pluses, those are the minus, you know? When this happens, minimum, you know, of f. When this one, remember this picture, means max. And when this happens, chain of concativity, you know, at this point.
Okay.
All you have to do is to check and say, a prime x was 50 minus 2x, and a prime second x is minus 2. Always constant.
Okay.
Which doesn't happen many times, you know. Maybe 2x squared, and then if I had to put a 25, you have to put here a 25, you know. But when there is not x, even at 25, it's minus 2, you know. Then, at any x, this means, like that, minimum or maximum?
It's a maximum.
Maximum, okay? Then, as a second of 25 also gives minus 2, negative, there is a max at x equal 25. The maximum value is
equal to x times 50 minus x.
then the real value, is 25, which is the maximum that I'm going to calculate, is 25 times 25, 625. Okay? A comment. When you find the maximum or minimum of a continuous function whose derivative is also continuous, that gives me all the power of using f prime f second, you have a problem. This is a continuous function over R, you know, over all R, you know. The maximum will be here, or maybe do like that at the sign or something like that, and have several relative maximums and several relative minimums. Critical points. One critical point, and as I show here, 4 or more. Calculus gives you the abscissa of the critical points, and then you find the y and you get the critical points. And with the second derivative, if at the critical points is negative, it's a maximum, and if the critical point is positive, it's a minimum. But it may happen like this, that you get a closed interval or open anyway. Let's see it is closed.
Instead of 0, 50.
I'm gonna put a and b. And you have a function here, very nice, continuous with second derivative continuous. Goes like this, you know.
Let's suppose
All these x are valid values, even x equal a and x equal b, okay? Over here, critical point, the x of the critical point, the x. But over here, it doesn't do like this, neither like that, neither like this, you know? Okay? It finished. Because I am between A and B. This value doesn't matter to me. This is a relative max. But if you check like over here is the max. Is in the domain and is greater than any other pretended max. This is a relative max, but fortunately or unfortunately, there is a max over here. It is not a matter of derivatives, but because when you evaluate the function, it is greater than this one. Then, when you are using maximum or minimum values in closed interval like this, you better check the endpoints.
Okay.
But in this case, even that they say, in theory, when I have sy and an area, when x equals 0, It gives me you like this, you know, right?
Right.
In this example, the maximum value of x or y was 25. And here the area is 0. It is true, the 0 is the minimum number of any in case of greater than or equal to 0. Then find the mean x equal y minus 25. We know that when y is 25, this is 0, and the area is 0, you know? In abstract, the real answer with no calculus is the mean of A is 0 when x is 0, you know? But in practice, you say, you are kidding. Where is my fence? What happened with my fence? You know? No chicken, no garden. Okay? Theory is close to practice. But when you are in this kind of problems, be careful. And say, okay, it is right, but no chicken, no garden, you know? Right? Okay? No garden. It's 0, but no garden, you know? Okay. And it is not matter of derivatives because the critical point gave me 25. No? 0 was not the critical point. But anyway, you better check the values of x equal x times x minus 25. When x equals 0, ax gives you 0, you know?
Yes.
When x equals 25, ax gives you also 0. Okay? Oh, I'm sorry, what happened? Was not that the function?
Yeah.
It's 50 minus x, you know? It's 50 minus x, you know?
Yeah. So.
I'm sorry. It's 50 minus x. It's 50 minus y, which is also true, you know? Right?
Yes.
The answer for mean was at x equal 25 and gives me a equal, when I put 25, right?
Yes.
25 over here. X, I don't know why. Right, 50 minus y. This is 50 minus x. This is 50 minus x. Okay. 825 gave me 625. Yeah, and this is, but a 0, which is this one, right?
Yes.
A 0 gives me 0, minimum value, no garden. Okay?
Okay.
And A50 gives me 0 also. Okay? Right? This function really is doing like that. If 0 gives 0, and 50 gives 0, and at 25 gives the maximum, you know? Then, if this is the maximum, this is not the maximum because it's 0, you know, right? But if you find a maximum like this, oh, I'm sorry, a maximum or a minimum, or a maximum like this, like that, like this, like this. You got the maximum here, but it doesn't compete with that. It's a maximum. Let's see. You may have this, doing like that, doing like this, doing like this. Oh, like this. Okay. Here is a relative critical point and relative max, you know, using calculus. But here, this is bigger, you know?
Yes.
Then this is not the mass, okay? Right? Or maybe it's like that, you know? Which is much better.
Yeah.
The mass is really here. And then see, if you are selling shoes and get the maximum profit, don't use this one, you know?
Okay.
Use this one. But here, the function goes like that. No derivative equal to 0, no critical point. Okay? Then when you are working with closed intervals, check these 3 points, the end points, you know? If it is open, those points doesn't compete, because even that the function is going like that, it doesn't end. No way to say which one is the bigger, you know? Right?
Right.
The bigger is that, but it doesn't exist, you know? Because it's open. Right. Then, I advise you, you have the atom